start proving triangles are congruent. So let's look at this proof. Here I'm told that AB, segment AB equals BD, which I already marked off for you. And we have that CB equals BF, which I also marked. We want to prove that triangle ABC is congruent to triangle DBF. Now when I think about triangle congruence, I should first start by working backwards, thinking about which postulates do I have in my toolkit that I could use. So we know we have SSS, that's proving all three sides. We have SAS, that's two sides in the included angle, 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 side, and angle, side, angle. So when I look at this, I already can look at the picture and tell that angle 1 and angle 2 are going to be congruent because they are vertical angles. So when I look at what I have marked congruent, I notice that I could use side, angle, side. So I already know, looking at this picture, that I'm going to use SAS to prove the triangles are congruent. So I'm going to get my T-chart together to get this proof going. So again, my first step is my given, which I can just write as given. And remember, those were that the sides were congruent. Even though I marked the picture, it wasn't in my given that 1 and 2 were congruent. So I'm going to have to clearly state angle 1 is congruent to angle 2. My reason for that is that vertical angles are congruent. And now my last step is to state that the triangles are congruent. Triangle ABC is congruent to triangle DBF because of side, angle, side. Now again, the nice thing about these triangle proofs is that it's like a checklist. So if I know I'm going to use SAS, let's see, did I prove that a pair of sides are congruent? Yes, I did, because I proved that AB is equal to BD. That was given to me. Did I prove the angles were congruent? Well, yes. The angle between the sides were angle 1 and angle 2. And did I prove another pair of sides congruent? Yes, I did. CB equals BF. That was given to me. So I did side, angle, side. Let's do another one. Here I have that AB equals AD, which I already marked. And I also stated that angle 1 is congruent to angle 2. If I'm trying to prove these triangles are congruent, I'm going to take a moment to study the picture. So if you look, you notice that AB and AD are marked congruent, angle 1 and 2. And then if I notice that the two triangles are conjoined, they share this side, AC. When I think about the postulates I have, so we have side, 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 angle, side, angle, side, angle, 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 side. Now when I look at this picture, I wasn't given any other angles, so I know that the two angle ones are not going to work for me. When I look at this, I wasn't told if BC and CD are necessarily equal, so I can't use S side, 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 SSS. When I look though, I do have what we call, I have a pair of sides, I have the included angle, and then I have a third side. That's called SAS. So now I'm going to have to clearly state that in my proof. So I'm making my T-chart. So my first step was my given, where I had AB equals AD, angle 1 congruent to angle 2, and that was all given to me. Again, I'm trying to prove that the triangles are congruent, and I know I'm going to use SAS. So look, I already have the side, I have one pair of sides, AB and AD. Do I have the included angle? Yes, 1 and 2. So now I need to prove that third side between the two triangles are congruent. So how I state that is that AC is congruent to AC. That's called the reflexive property. Again, to use SAS, I need to clearly state that there's a pair of sides, so I have AB equal to AD, the angle, angle 1 and 2, and then the third side would be AC. You have to think of it as, what if those triangles were not connected? So I have AB and AD, angle 1 and angle 2, and then that third side, that second side, pair of sides would have to be congruent. So that's why I need to state AC is congruent to AC between the two triangles. And now I have triangle ABC is congruent to triangle ADC by side, angle, side. You might ask, why can't I use another postulate? I have to go by the given information, that I have enough information to prove. But let's do another proof. So in this proof, I'm told that, let me move this over. Okay, so in this proof, I'm told that C is the midpoint of BD. I'm told angle 1 is congruent to angle 2, and that AC is congruent to CE. So based on the given stuff, I already have a pair of sides and two angles congruent. Let's also look back at what this step means. If I was given that C is the midpoint of the segment BD, then when I think about it, well, the definition of a midpoint is that it bisects the segment. So that would make BC congruent to CD. So now I'm trying to prove that the triangles are congruent. So let's use my T-chart to write it all out. Take a moment to think, which postulate would you use to prove these two triangles congruent? So if you analyze your picture, you have enough information to prove side, angle, side. So we're going to use SAS here. So for SAS, did I clearly state that there was a pair of sides congruent? Well, yes, AC equals CE, that was given. Did I prove a pair of angles were congruent? Well, yes, angle 1 and angle 2 are congruent. Did I clearly state a second pair of sides are congruent? Well, my given told me that C is the midpoint, but I need to clearly state that BC is congruent to CD because of the definition of a midpoint. And so once I state that, I have enough to prove that triangle ACB is congruent to triangle ECD by side, angle, side. For this example problem, I'm told that AD is congruent to DC, that B is the midpoint of AC. That's all I'm given. So let's take a moment to analyze the picture and see which postulate do I have enough information to prove. So remember, here's a list of postulates that we'd be looking at. So when I look at this one, I'm told AD and DC are congruent. I'm also told that B is the midpoint of AC. Well, if B is the midpoint, that means that it would divide AC into two congruent parts. So I can prove AB and BC are congruent. If I analyze the picture even further, I notice that both sides share this segment, DB. So I'd be able to state that DB between the two triangles is congruent. When I'm looking at the postulates, well, I have enough information to prove side, side, side. I have to make sure that I clearly state that three pairs of sides are congruent. So if I don't want to write out my whole given, I can just write given and given. So again, for SSS, did I clearly state one pair of sides are congruent? Well, yes. I was told AD is equal to DC. So I already stated one pair of sides. I need a second pair of sides congruent. So even though I marked it in the picture, I have to remember to actually write it in my proof. So if B is the midpoint, it means AB is congruent to BC. And my reason for that is definition of a midpoint. And now for my second to last step, I have to prove that that third pair of sides are congruent. Well, I notice they both share DB, so I'm going to use what's called the reflexive property. And now I've clearly stated all three pairs of sides are congruent, so now I can state that triangle ABD, oops, let me make sure that, so triangle ABD is congruent to triangle CBD. And my reason for that would be side, side, side. Okay, so what I'd like for you to do now is try the next two proofs on your own. So you can try them on your own and then go over, here's another one that I want you to try. Try them on your own and you can compare your answers with your table mates and we will go over the answers together.